Article 517 of the National Electrical Code, or NEC, covers healthcare facilities. For general wiring methods, healthcare facilities metallic cable, or HCF-MC cable, is permitted for all wiring in healthcare facilities. MC cable provides protection against physical damage and interference from other electrical systems. For emergency system wiring, emergency lighting and emergency outlets must be fed from the generator panel. Emergency lighting in operating rooms may have built-in batteries as a backup. Since the suite is backed up by a generator, HCF-MC cable is the correct wiring method for all circuits, including general lighting outlets except for emergency outlets and equipment circuits. There are some exceptions. Communication circuits and fire alarm circuits may be installed in separate conduits. Considering the specific requirements for a healthcare facility with emergency power, let's delve deeper into the NEC articles and sections that govern electrical installations in such environments. Firstly, understanding the scope of Article 517 is crucial. It applies to electrical installations in healthcare facilities that provide services to patients. These facilities include hospitals, nursing homes, clinics, and other medical establishments. The NEC defines various types of healthcare facilities based on the services they provide and the level of patient care they offer. These classifications determine the specific wiring and equipment requirements that must be followed to ensure patient safety and prevent electrical hazards. Secondly, grounding and bonding are essential aspects of electrical safety in healthcare facilities. The NEC mandates that all metallic equipment and conductive surfaces within the patient care vicinity must be properly grounded and bonded to minimize the risk of electric shock. This includes grounding receptacles, lighting fixtures, medical equipment, and other conductive surfaces that patients or healthcare personnel may come into contact with. The grounding system must be designed and installed to provide a low impedance path for fault current to flow back to the source, which will trip the circuit breaker and energize the circuit. Thirdly, isolated power systems are often required in critical care areas such as operating rooms and intensive care units. These systems use an isolation transformer to electrically isolate the patient care area from the main power supply. The isolation transformer prevents ground faults from causing a shock hazard to patients or healthcare personnel. An isolated power system typically includes a line isolation monitor, or LIM, which continuously monitors the impedance to ground. If the impedance drops below a certain threshold, the LIM will alarm, indicating a potential ground fault. Healthcare facilities metallic cable, or HCF-MC cable, is a specialized type of cable that is designed for use in healthcare facilities. It has a metallic sheath that provides mechanical protection and also serves as an equipment grounding conductor. HCF-MC cable is often required in healthcare facilities to minimize the risk of electrical noise and interference, which can disrupt sensitive medical equipment. Emergency power systems are critical for maintaining essential electrical services during a power outage. Healthcare facilities must have an emergency power system that is capable of providing power to essential loads such as lighting, life support equipment, and critical medical devices. The emergency power system must be designed and installed to meet the requirements of the NEC and other applicable codes and standards. The transfer switch is a key component of the emergency power system. It automatically switches the essential loads from the normal power source to the emergency power source when a power outage occurs. The transfer switch must be designed and installed to ensure a reliable and seamless transfer of power. Operating rooms have specific electrical requirements due to the critical nature of the procedures performed in these areas. The NEC requires that operating rooms have a separate dedicated electrical system that is isolated from the general electrical system. This system must include an isolated power system, emergency power, and other specialized equipment to ensure patient safety. Wet locations, such as hydrotherapy rooms and patient bathing areas, have additional electrical safety requirements to prevent electric shock hazards. The NEC requires that ground fault circuit interrupters, or GFCIs, be installed in these areas to protect patients and healthcare personnel from electrical shock. CFCIs are designed to detect ground faults and quickly energize the circuit, preventing a dangerous electrical shock. Receptacles in patient care areas must be tamper-resistant to prevent children from inserting objects into the slots. The NEC requires that all receptacles in patient care areas be listed as tamper-resistant. This requirement helps to prevent accidental electrical shocks and injuries. Signage is important for identifying critical electrical equipment and systems in healthcare facilities. The NEC requires that emergency power systems, isolated power systems, and other critical electrical equipment be clearly labeled with appropriate signage. This signage helps to ensure that healthcare personnel and maintenance staff can quickly identify and operate the equipment in an emergency. Maintenance and testing are essential for ensuring the continued safe and reliable operation of electrical systems in healthcare facilities. The NEC requires that electrical systems be regularly inspected and tested to identify and correct any potential problems. This includes testing emergency power systems, isolated power systems, and other critical equipment. Documentation is also important for maintaining a record of electrical installations, inspections, and testing. The NEC requires that healthcare facilities maintain accurate and up-to-date documentation of their electrical systems. This documentation should include wiring diagrams, equipment specifications, and inspection reports. Furthermore, the NEC provides specific guidelines for the installation of electrical equipment in hazardous locations within healthcare facilities. Hazardous locations are areas where flammable gases, vapors, or dust may be present, such as laboratories or storage areas for flammable materials. Electrical equipment installed in these locations must be designed and installed to prevent ignition of the hazardous materials. Another important consideration is the coordination of electrical systems with other building systems such as HVAC, plumbing, and fire alarm systems. The NEC requires that electrical systems be coordinated with these other systems to ensure that they operate safely and effectively. This coordination includes considerations such as emergency shutdown procedures, ventilation requirements, and fire protection measures. The selection of appropriate wiring methods and materials is crucial for ensuring the safety and reliability of electrical systems in healthcare facilities. The NEC specifies the types of wiring methods and materials that are permitted for use in different areas of healthcare facilities, based on factors such as the occupancy classification, the environmental conditions, and the potential for physical damage. Training and education are essential for healthcare personnel and maintenance staff who work with electrical equipment. The NEC requires that these individuals receive adequate training on electrical safety procedures, the operation of electrical equipment, and the identification of potential hazards. Proper training helps to prevent electrical accidents and injuries. The use of surge protective devices, or SPDs, is recommended to protect sensitive electronic equipment from voltage surges. SPDs are designed to divert excess voltage to ground, preventing damage to equipment. The NEC provides guidelines for the selection and installation of SPD in healthcare facilities. The NEC also addresses the requirements for low-voltage systems in healthcare facilities, such as nurse call systems, communication systems, and security systems. These systems must be designed and installed to meet the requirements of the NEC and other applicable codes and standards. The NEC includes provisions for the use of alternative energy sources, such as solar photovoltaic systems and wind turbines, in healthcare facilities. These systems must be designed and installed to meet the requirements of the NEC and other applicable codes and standards, and they must be properly integrated with the existing electrical system. The NEC also addresses the requirements for temporary electrical installations in healthcare facilities, such as those used during construction or renovation projects. Temporary electrical installations must be designed and installed to meet the requirements of the NEC and other applicable codes and standards, and they must be removed promptly when they are no longer needed. Furthermore, it is important to consider the impact of electromagnetic interference, or EMI, on sensitive medical equipment. EMI can disrupt the operation of medical equipment and lead to inaccurate readings or malfunctions. The NEC provides guidelines for minimizing EMI in healthcare facilities, such as using shielded cables and grounding techniques. The NEC also addresses the requirements for electrical systems in healthcare facilities that are located in floodplains or other areas that are subject to flooding. These systems must be designed and installed to minimize the risk of electrical hazards during a flood. This may include elevating electrical equipment above the flood level or using waterproof enclosures. The NEC also includes provisions for the use of uninterruptible power supplies, or UPSs, in healthcare facilities. UPS provide backup power to critical equipment during a power outage. The NEC specifies the requirements for the selection, installation, and maintenance of UPS in healthcare facilities. It is also important to consider the accessibility of electrical equipment for maintenance and repair. The NEC requires that electrical equipment be installed in locations that are readily accessible for inspection, maintenance, and repair. This ensures that electrical systems can be properly maintained and that any problems can be quickly addressed. The NEC also addresses the requirements for electrical systems in healthcare facilities that are located in coastal areas or other areas that are subject to corrosive environments. These systems must be designed and installed to resist corrosion and to ensure that they operate safely and reliably. This may include using corrosion-resistant materials and applying protective coatings. The NEC also includes provisions for the use of power quality monitoring equipment in healthcare facilities. Power quality monitoring equipment can be used to identify and address power quality problems such as voltage sags, voltage swells, and harmonics. These problems can disrupt the operation of sensitive medical equipment and lead to inaccurate readings or malfunctions. The NEC also addresses the requirements for electrical systems in healthcare facilities that are located in areas with high seismic activity. These systems must be designed and installed to withstand seismic forces and to ensure that they continue to operate safely during and after an earthquake. This may include using flexible connections and anchoring equipment to the building structure. The NEC also includes provisions for the use of arc fault circuit interrupters, or AFCIs, in healthcare facilities. AFCIs are designed to detect arc faults, which are a common cause of electrical fires. AFCIs can help to prevent electrical fires by quickly de-energizing the circuit when an arc fault is detected. It is also important to consider the security of electrical systems in healthcare facilities. The NEC requires that electrical systems be protected from unauthorized access and tampering. This may include using locked enclosures and security cameras. The NEC also addresses the requirements for electrical systems in healthcare facilities that are located in areas with extreme temperatures. These systems must be designed and installed to operate safely and reliably in the extreme temperatures. This may include using temperature-rated equipment and providing adequate ventilation. The NEC also includes provisions for the use of smart grid technologies in healthcare facilities. Smart grid technologies can help to improve the efficiency and reliability of electrical systems. These technologies include smart meters, demand response systems, and energy storage systems. The NEC also addresses the requirements for electrical systems in healthcare facilities that are located in areas with high winds. These systems must be designed and installed to withstand high winds and to ensure that they continue to operate safely during a storm. This may include using wind-rated equipment and anchoring equipment to the building structure. The NEC also includes provisions for the use of wireless communication technologies in healthcare facilities. Wireless communication technologies can be used to transmit data and control electrical equipment. These technologies must be designed and installed to minimize the risk of interference and to ensure that they operate safely and reliably. The NEC also addresses the requirements for electrical systems in healthcare facilities that are located in areas with heavy snowfall. These systems must be designed and installed to withstand heavy snowfall and to ensure that they continue to operate safely during a snowstorm. This may include using snow-rated equipment and providing adequate support for overhead conductors. The NEC also includes provisions for the use of energy management systems in healthcare facilities. Energy management systems can help to reduce energy consumption and lower utility bills. These systems can be used to control lighting, HVAC, and other electrical equipment. The NEC also addresses the requirements for electrical systems in healthcare facilities that are located in areas with frequent lightning strikes. These systems must be designed and installed to protect against lightning strikes and to ensure that they continue to operate safely during a thunderstorm. This may include using lightning protection systems and surge protective devices. The NEC also includes provisions for the use of renewable energy credits, or RECs, in healthcare facilities. REC can be used to offset the environmental impact of electricity consumption. Healthcare facilities can purchase REC to support renewable energy projects and reduce their carbon footprint. The NEC also addresses the requirements for electrical systems in healthcare facilities that are located in areas with poor air quality. These systems must be designed and installed to protect against the effects of air pollution and to ensure that they continue to operate safely and reliably. This may include using air filtration systems and corrosion-resistant materials. The NEC also includes provisions for the use of combined heat and power, or CHP, systems in healthcare facilities. CHP systems can generate electricity and heat simultaneously, which can improve energy efficiency and reduce emissions. The NEC also addresses the requirements for electrical systems in healthcare facilities that are located in areas with limited access to electricity. These systems must be designed and installed to maximize energy efficiency and to minimize the risk of power outages. This may include using renewable energy sources and energy storage systems. The NEC also includes provisions for the use of demand response programs in healthcare facilities. Demand response programs can help to reduce electricity demand during peak periods, which can improve grid reliability and lower electricity costs. Healthcare facilities can participate in demand response programs by agreeing to reduce their electricity consumption during peak periods. The NEC also addresses the requirements for electrical systems in healthcare facilities that are located in areas with a high risk of cyber attacks. These systems must be designed and installed to protect against cyber attacks and to ensure that they continue to operate safely and reliably. This may include using cybersecurity software and firewalls. The NEC also includes provisions for the use of blockchain technology in healthcare facilities. Blockchain technology can be used to track and manage energy consumption and to facilitate the trading of renewable energy credits. This technology can improve the transparency and efficiency of energy markets. The NEC also addresses the requirements for electrical systems in healthcare facilities that are located in areas with a high risk of natural disasters. These systems must be designed and installed to withstand natural disasters and to ensure that they continue to operate safely and reliably. This may include using disaster-resistant equipment and providing backup power systems. The NEC also includes provisions for the use of artificial intelligence, or AI, in healthcare facilities. AI can be used to optimize energy consumption, improve grid reliability, and enhance cybersecurity. This technology can help to create more efficient and resilient electrical systems. The NEC also addresses the requirements for electrical systems in healthcare facilities that are located in areas with a high risk of pandemic. These systems must be designed and installed to protect against the spread of disease and to ensure that they continue to operate safely and reliably. This may include using air filtration systems and disinfection technologies.